Mathematics is an important part of everyday life. You do simple math hundreds of times each day. You buy things and you count your change, you calculate the mileage your new car is getting, and many more things involving simple math. Sometimes the math you must do is a little more complex. If you're buying a house, you'll need more advanced functions to determine your payments given a particular interest rate, amount borrowed, and loan duration. If you're a scientist, engineer, or machinist, or you have one of the many occupations that require the use of more advanced functions, you'll appreciate the power inherent in VBA's math functions. If you think math is too difficult or you don't have a practical use for it, consider some of the examples you're about to see. Everyone uses math to make life easier, and VBA provides you with the functions to perform that math more quickly and accurately. You'll notice that I have the companion workbook for this session already open on the screen here, and I want to get into the Visual Basic Editor. And you can see, if you look in the Project Explorer over here, that there are 4 modules that are included in this workbook. It's these 4 modules that we're going to go through because they contain the macros that will illustrate the power of the numeric VBA functions. Now understand, I won't be focusing on all of the numeric functions available, but instead on the most commonly used functions. I'll be doing that in this session and the following 2 sessions of the course. To introduce you to the power of the numeric VBA functions, let's say that you are just interested in the portion of a number to the left of the decimal point. The int or int function returns it for you. This is handy in some mathematical calculations where you need to make sure that you are working with whole numbers. So let's go ahead and take a look at a simple example that is contained in Module 1, which is up on the screen right here. You'll see that there's a macro called integer1, and that's the one that we're going to be working with. You will also see that what this macro does is it declares 3 variables up here at the beginning. It assigns a value to the d-original variable, and then it sets myInt, which is an integer variable, to the int, or the integer portion of that d-original variable. And then it displays what is contained in all of that information here. Now notice that we use the double, integer, and string data types up here at the beginning where we're declaring our variables. You'll remember that we talked about data types earlier in the course. Now I'm going to go ahead and I'm going to run this macro so you can see what it returns. And it shows us the original number and the converted number after going through the int function. Notice that everything to the right of the decimal point was wiped out entirely through the use of that int function. When the code is executed, as you just saw, the myInt variable contains the value 52, everything to the left of the decimal point, which is the integer portion of the original number. Note that the int function simply truncates everything to the right of the decimal point. It does no rounding at all. If you want to round the number, then you need to make some modifications to the macro to take advantage of another VBA numeric function. So I'm going to go in here and I'm going to make a few changes to this code so that you can see how we would do that. Okay, I'm done with the changes to the code, and you can see that all that I did is I added in a new variable called imyRound, and then I added a calculation in there that uses both the int function and the round function to operate upon that value that's stored in d-original, and it assigns that to the imyRound variable. And then I modified what is shown in the message box so that you can see the results of what the macro is doing. So we're going to go ahead and run this, and you can see that the rounded result is different than the result that just relies on the int function. The rounded result actually rounds to the number 53. So what if you're interested in only the decimal portion? Well, that's quite simple actually. All you have to do is subtract the integer portion from the original number. If we go over here to Module 2, you can see an example of what I'm talking about. You'll notice that we use variables that are very familiar. They're similar to what we used in the earlier macro. And we assign the value to d original. And then right down here what we do is we take the int portion and assign it to I my int. And then we say that the decimal portion is equal to the original minus that integer portion of the number. And that's how we get what is just to the right of the decimal place. And then we display the results of what we're doing on the screen. So we're going to go ahead and we're going to run this one, and you can see that the original number is here, the converted number is 52, and then the decimal portion is everything that was to the right of the decimal place. Now you'll notice that this portion that's to the right of the decimal place is quite a bit longer. It doesn't exactly match the 5 digits to the right of the decimal point in the original number. This has to do with how values are stored in memory by VBA. And this can get a little bit tricky, and you may want to check how your macros work to determine the best way to proceed. The way around the problem in this case is, again, to rely on the round function. This time, however, the usage of that function will be just a little bit different. So let's get back to our macro here, and I'm going to make a change in this line right down here. And that's it. That's the change. Notice that we used the round function, but after the subtraction is done, we indicate that we want to round to 5 decimal places when we run it. So if we go ahead and we run this again, you can see the results look much better than what they did before. For this portion of the session, we are going to be working with the macro that is contained in Module 3. I've gone ahead and opened that on the screen, as you can see. You can open it just by clicking over here or double-clicking over here on the Module 3 in the Project Explorer, and then it should display right on your screen as you see here. When performing mathematical operations, it is sometimes necessary to know the sign of a number or whether it is equal to 0. For example, before dividing a number by a variable, it is good to know whether the variable is equal to 0. If it is, then the result of the division is referred to as being indeterminate and shouldn't be performed because an error would be generated in your macros. This is what happens when you divide something by 0. Similarly, if you are about to take an even root of a number, you most likely want to know if that number is negative or not. The SGN, or sign function, determines whether a number is equal to, greater than, or less than 0, all in one step. This is better than first testing the value to see if it is equal to 0 and then testing to see if it is greater than 0 or less than 0. The sign function is faster and more compact. You'll notice right up here in the macro that we declare our variables, and then I specify that I my value is equal to -3. Notice the use of the sign function right down here where I assign to the I my sign variable what is returned by the sign function. And then I specify, or I set up what the message is going to be so that I can display the message. I'm going to go ahead and run this just so that you can see. Now notice or remember that I my value is equal to -3. If we run this, we see that -3 is less than 0, which is exactly what we would have expected. But if I go ahead and I change this to a +3 just by getting rid of the negative sign and run it, it should tell us that 3 is greater than 0 because the sign function told us that it's greater than 0. And finally, if I set that actually equal to 0 and run it, then we can see that 0 is equal to 0. That Sounds almost like a no-brainer, doesn't it? Now there's conditional statements that are used in this macro, and they might throw you off for a moment. They are covered completely a little bit later in the course. The important thing to remember is that the sine function returns only 3 possible values. If the value used as a parameter is a negative number, sine function returns a -1. If the value used as a parameter is 0, then the sine function returns 0. If the value being used as a parameter is a positive number, then the sine function returns 1. For this portion of the session, we'll be working with the macro that is contained in Module 4. So go ahead and open up Module 4. As you can see, it's open on the screen here. And you can see that there's a macro called find square root. Again, we specify our variables up at the beginning, and we allow the user to specify what number they want to use in order to find out what the square root of that number is. In some calculations, such as square roots, negative numbers are not acceptable unless you're prepared to write special and highly complex routines for handling imaginary numbers. And that's not an easy task to do in VBA. Sometimes the calculations can continue by ensuring that the number is positive. You could test a number before using it and multiply it by -1 if it was negative, thereby changing its sign, but there's actually an easier way. The guaranteed result of the ABS function, or the absolute function, is a positive number. That's the function that we're using here within this macro. It returns the positive value of any number that's used as a parameter. Thus, if the number was originally negative, it is changed to positive. If the number was positive, it remains unchanged. So you can see that when somebody enters in a number, then we check to make sure that that number is absolutely positive by using the ABS function right here in the middle of the macro. So I'm going to go ahead and run this, and it asks me for what number I want to use. And if I say a positive number such as 62, then I say OK, and it tells me that the square root of 62 is this number right here. If I go ahead and run it again, but this time I say that I want to do -43, then what should happen is, remember that the ABS function is used to convert this to a positive number, so we can see that the square root of -43 is this. It's not actually the square root of -43. Remember that the -43 was converted into a positive number, and this is the square root of the positive version of that number. Using the ABS function within the square root function guarantees that an error won't occur if the dsource variable contains a negative number. I remember the days when Excel was first introduced, and its claim to fame, like that of most other spreadsheet programs, was it could crunch numbers easily and quickly. True to those roots, it is important that VBA allows you to also crunch numbers. While VBA doesn't have as many built-in functions as Excel itself does, it provides a good number of numeric functions that are essential when you are working with numeric data within your macros. Now in the next session, I'll continue introducing you to some of the numeric functions provided in VBA. Specifically, I'll show you how to work with random numbers.